Alright, let's take a look at problem 8-13A, which is a basic variance analysis problem. Um, I think it's relatively legible, but near the bottom we're going to have a bit of a struggle, so let me read it. Riley Labs produces various chemical compounds for industrial use. One compound is called Lundor, and it's prepared using an elaborate distilling process. And the company has developed cost for 1 unit of Lundor, as you can see on the screen right here. Alright, then we've got items A through E that we need to understand. Item A says material purchased was 11,500 ounces at a cost of $236,900. And rather than read the rest of them, let me just slide down. We can get to the requirements, and we'll read what we need to. Okay, so it says for direct materials used in the production of Lundor, compute the price and quantity variances, and then on B, it tells us that the materials were purchased from a new supplier who's anxious to enter into a long-term purchase contract. Would you recommend we sign the contract? All right, so let's focus on the direct materials. We see to the left of my mouse the materials purchased 11,500 ounces at a cost of $236,900. So let's work on computing the price variance. And we have the standard as being, what is that, 2 ounces, $22 per an ounce, or $44. Okay, and they purchased 236,900. So let's work on the material price variance first. I'm going to do this in a relatively straightforward way. Remember that the material, let me type this out here, materials price variance is equal to the actual quantity times the actual price less the standard price. Okay, now rather than using the column approach, we'll use it this way. All right, so what they actually purchased was 11,500 ounces, right above my mouse there. Okay, so what we know is we've got 11,500. Let me just type in the formula and we can do this. 11,500 times, and the actual price paid was, oh, we have to calculate that. Let's do it a little bit longhand then. So here we have ounces purchased, and the price we paid was equal to, wasn't it 200 and let me get that number again. 236,900 was the total amount we paid. So the cost per ounce, take the cost divided by that, and we come up with $20.60 per ounce. Okay, so that's the cost per ounce. The standard per ounce was equal to $22 per ounce, right? Okay, and let me format that the same way. Just format that like that. All right, so now if we use that formula, let me slide this down here, and we will take the actual ounces times the actual price paid per ounce, which was $20.60, minus the standard price per ounce, okay, and that's showing it in brackets because the actual price was actually less than the standard price. So this represents a favorable variance. Now, what I'm going to do is reverse the signs. Rather than showing favorable in brackets, even though that represents a credit, I prefer to use positive variance as being positive and negative as being in brackets. So what we come up with is 16,100 favorable price variance. Okay, now let's put together the material usage variance or material quantities variance. Our text calls it quantity. In my experience, it's also called usage. And that then is equal to the standard price times the actual quantity minus the standard quantity. Okay, so what do we know? The standard price, we can copy right from here, is $22. The actual quantity is 8,500 ounces, and here's how we know. They tell us to the left of my mouse in item B, it says there was no beginning inventory of materials, but at the end of the month 3,000 ounces remained in ending inventory. So if we purchased 11,500 and had 3,000 at the end, then 11,500 less 3,000 gets us to 8,500 of the actual ounces used. So let's drop in that, which was 11,500 less the 3,000, or 8,500 actual quantity used. Okay, then the standard quantity allowed for this amount is equal to, okay, the standard quantity is 8,400 ounces, and how we know that is item E says during November 4,200 good units were produced, and in our standard we see the standard quantity is 2 ounces, so we take the 4,200 times 2 to come up with 8,400. So let's drop that in. 4,200 units produced times 2 ounces per unit is 8,400. Now we can slide our materials quantity variance and do that calculation, which is equal to the standard price times the difference between actual quantity less the standard quantity. Okay, and we come up with 2,200. Now, I'm going to reverse the numbers. I actually wanted to take the standard minus actual so that it shows unfavorables will show up as a bracket. So this is an unfavorable material, I'm going to abbreviate here, quantity variance. Okay, that takes care of part 1A. Now, on 1B they say, slide on down, the materials were purchased from a new supplier who's anxious to enter in a long-term purchase agreement. Would you recommend we do that? Well, just based on our information that we've got favorable price coupled with an unfavorable material usage, we could conclude that the contract probably should be signed. The new price of $20.60 is substantially lower than the old price of $22 per ounce. Where do we find the old price? Right there. We're assuming the old price was based on the standard. Okay? And that results in a favorable price of $16,100. What we also see is the material from the new supplier appears to cause little or no problem in production. And the reason we're coming up with that is, although we were unfavorable, the dollar amount of the unfavorability is $2,200. So if this is all the facts we have, and we could conclude this that either this unfavorable variance is caused by the new materials or is caused by some other source, in either way, 16,100 less 2,200 is a nice positive number that seems to tell us that if there is an unfavorable material quantity price variance, it's relatively small relative to the benefit we'll get from entering into a long-term contract at the $20.60 cost per ounce. And that takes care of part 1A and part 1B. Okay, now on part 2 it says, for direct labor employed in the production of Lundor, compute the rate and efficiency variance. So let's and that's to the left of my mouse. Let's handle that part. Okay, so a labor rate variance would be equal to the actual hours times the actual rate minus the standard rate. Let's see if we can find all of these. We need actual hours, we need the actual rate, and we need the standard rate, right? Okay, now the actual hours are the 36 lab technicians times 160 hours. So if we take the 36 times 160, was that correct? I think that's correct. Yeah, 36 times 160. It's 5,760 was the actual hours. And the standard rate is $12 per hour. And they earned an average rate of $11.90. So now let's format those. And from here we can then slide this down, actually do the calculation. Takes the actual hours times the actual rate minus the standard rate. And we come up with 576. But again, this uses the formula as if the actual rate was more, so that the bracket would be a favorable. And I prefer it to work the other way. Apologize for my my throat clearing. I have a bit of a sore throat. So 576 is the favorable rate variance. Okay, now to do the labor efficiency variance, that would be equal to the standard rate times the actual hours minus the standard hours, right? Okay, so we know the standard rate. Now let's see if we can just copy some of this down. The standard rate is $12 per hour. The actual hours was the 5,760. I'll jot that down again. But the standard hours would be equal to something different. To compute the standard hours, we know that we made 4,200 good units, and we're supposed to be using 1.3 hours per unit. So if we move over here and type in 4,200 units times equal 4,200 units times 1.3, we come up with 5,446, and that's the standard hours allowed for the good units produced. Okay? And now I'm going to slide this one down, and we'll do that formula again. I think I can just copy from here and it should just work just fine. Yeah, and at this point it's already flipped the sign. Keep in mind that if we take actual hour minus standard hours, we're going to get an unfavorable variance that would show up as positive, but since I copied from below, I've already reversed that so that it shows up in brackets, which is the way I like it, and that's an unfavorable labor efficiency variance. Okay, now that takes care of Part 2A. Part 2B says, in the past, the 36 technicians employed in the production of Lundor consisted of 21 senior technicians and 15 assistants. During November, the company experimented with fewer senior, technicians and 15 assistants. And I think maybe I may have cut off the bottom, so let me read it from the source. During November, the the company experimented with fewer senior technicians and more assistants in order to save cost. Would you recommend that the new labor mix be continued? Okay, so now what we do is we look at the variance and we see that we had 506 favorable rate and 3,600 unfavorable labor. So if given those facts, we'd say no, the new labor mix is probably should not be continued. So although it decreased the average hourly cost from $12 to $11.90, resulting in a small favorable rate variance, the savings was more than offset by an unfavorable labor efficiency variance for the month. And so overall, this does not look like a good decision to take.